Assalamualaikum and good morning to everyone. So welcome back after the semester break. Can you hear me? Okay. So hope you have rested a bit for 1 week, right? Did you rest or did you get more work? No rest, more work. Okay. So what to do? As long as the semester didn't finish yet, of course you will have to do your assignment, do your exercises, right? What to do? You have to finish one semester, then you can rest a bit. So what I have given you before the break was to prepare the sequence diagram for the PBL2, right? So that was the thing that I asked you to do during the break. And also I asked you to send me the sequence diagram that you have drawn for checking, right? So I have received only from 5 groups, right? So far, 5 groups have emailed me for checking. So I have checked them and I have given them feedback. So I'm still waiting for 4 other groups who did not show me the sequence diagram yet. So I hope you can show me after class, right? So that we will all be in the same pace, right? Same pace for so that we will not be left behind and other groups are already in front. Okay. So for the groups that I have checked, I have found some mistakes. Some groups a lot more. Some groups a few mistakes. So try to correct them because all the mistakes that you have done will affect the marks, right? Because the marks are going into details about how you name the actor, how you name the objects, how about the message flow, does it correspond to the use case spec or not, right? So in case you have to add something to the use case spec, you can add, right? You can add for the final PBL submission. I will be checking it against the new spec. Later I will inform you what you submit for PBL2. So far we need to finish sequence diagram by this week, so that next week we will can draw the class diagram, and that will conclude the PBL2. Okay, so after class, please those group that I didn't check your sequence diagram yet to stay behind and show me. The groups that I already checked, no need to stay behind. I might check you later, or maybe I don't need to check you because I already give you feedback. Okay, so today what we are going to do is to finish up our last slide on week about the sequence diagram. There is one slide that we didn't discuss because I was waiting for you to finish drawing the sequence diagram first. So we will go to that slide and we will finish it off. After that, we will go to our new topic, class diagram, and we will start to see what are the symbols that we use for class diagram, what are the components that we need to fill up, how are we going to draw the class diagram, and so on in that topic. So we will finish that topic today about the class diagram. Most probably we will keep the design class diagram for next week. So actually we are really on schedule. So what we have planned is today we are really following our schedule, and that's good, right? Because if we don't follow the schedule, then we will feel like our time is too tight to finish up our PBL and all the syllabus for the class. So good job. This one is because of your hard work, right? You have done you are following the schedule, you're submitting on time. So this is what I want, right? As long as you submit on time and you show me your progress, that is good enough. Okay. All right. So what else? Okay. Another thing that I want to remind before before I forget is our next quiz 2, right? We will be having it next week, right? Next week, Thursday, we will having our next quiz 2 on Thursday next week. Topic is topic 3 and 4, right? Topic 3 and 4, which is the UML diagrams, all the diagrams that we learn about, the introduction of behavioral models, static model, and topic 4 is about use case, right? So there will be question of on use case diagram, the extend relationship, the include relationship. So you have to understand those things for the quiz. So okay, that's it. That's the things that I want to tell you before we start our lecture. So if you have any questions, you can write down on the chat. Any questions? Okay, let me share the PowerPoint slide. So you can see the slide for previous week. Go to the last slide. All this we have discussed, except for this one. Okay, one moment. Welcome. Okay. So for this slide, actually it's how to convert from sequence diagram to the class diagram. So because last week, before semester break, we didn't finish drawing the sequence diagram yet. So I didn't go through this slide. So now is the time to discuss this slide. How to convert our sequence diagram into class diagram, because they are related, right? So all the objects that we have drawn for our sequence diagram, so these are the objects, right? Okay, this one, the symbol here, we will go through later. This symbol, right? This symbol is the interface symbol. This one is a controller symbol. This one is the entity objects. Okay, this later we will talk about this. This one we call it stereotypes. So far you have drawn a sequence diagram with actor, and then you have the interface object, then you have the controller, and then you have all the entity classes, entity objects here, right? So how to each one of these, except the student, right? Except the actor, because actor is someone who is outside your system. Your system starts from the second object, the interface, right? So you have to draw one class for interface, right? So this is registration interface, right? So you can see here, there is in the class diagram, right here. Can you see the arrow? You can see my arrow, right? When I'm pointing. Yes or no? Yes. Okay. So so this is the registration interface that from here, from the sequence diagram, right? The name should be same. If here you put reg interface, then here also must be reg interface, right? And then there are 3 boxes here, right? For the attribute and the operation. So for the interface, we do not write down any information for attribute, but we write only the operations. So where do we get this operation from? Login and select course from the sequence diagram. Okay, there is an arrow going into the interface, right? Login and select course. So these 2 arrows that goes in must be written in the interface object. Okay, let's go to the second object, registration control. So where's registration control? It's here, right? Registration control. So what are the arrows that going in to the registration control? Request login and select course, and also calculate tuition. Okay, there's another arrow here that's going back to itself, right? This one also should be in the interface. Confirm registration email bill must be also in the interface, right? So just as an example here. So you can see there are 3 arrows going to the lifeline. So those would be its operation. Okay, let's check the entity objects. Student info. Student info got only one arrow going in, right? Can you see? There's no more arrows going in the lifeline. So only one operation for student info. And as you can see here, this is the class for student info, and we have one operation. Right, and then there is some attributes that we add depending on our system. This one we can add as we want, whatever attribute that we want for our student to keep information. So depending on how are you going to use the info. For example, here just for login, we need name, ID, address, user ID, password. As you can see, all the interface objects are here. Student info, class schedule, student schedule, and roster. These are all interface entity object. So all of them got attributes. Okay, attributes. Only interface and controller do not have attributes. And then same goes for the operation. You check arrows that going in. So class schedule got one arrow going in. Get class information. So there you have it here. Get class info. For student schedule, you have add course to student schedule. So that there you have it. Add course. And for the roster, we have add student name to class roster. So there you have it. Add student. Right. So for the naming of the operation, you can make it short. Doesn't necessarily to follow the messages that we have written. Sometimes messages are long, so you can make it short. So can you see the relationship between the class diagram and the sequence diagram? So if you have more than one sequence diagram, and then you have to combine it in a one class diagram. So let's say the second sequence diagram you have for course registration. So there is a course registration screen. So you just add a course registration screen here, but others may be are used by the same for second sequence diagram. Still use student info, still use class schedule. So you don't need to create another one. Just use the existing class that you have created. So we have a lot sequence diagram, but only one class diagram. Okay. So actually, this one I already told you when I showed the example for the PBL2 materials, right? I show you previous class students who have came out with a sequence diagram and class diagram. Okay, so that's it for this one. I think we have yes, class diagram include all the flows. It includes also the exceptional flow. Exceptional flow, sometimes we have like a messages saying display error message. So you have to put in the interface another operation, display error message. Okay, so whatever that goes in the lifeline must be in the class diagram. So that includes exceptional flow, alternative flow, all the flows. Any more questions?
In class diagram, between the student info and the class one student's schedule and dotted line.
Oh, this one, dotted line?
Dotted line. Yes, what means?
Okay, this is the relationship between student info and the class schedule, right? Actually, don't think about the association between classes yet, because we are going to discuss about the association now in our next class. For time being, I'm just showing you the relationship between the sequence and the class. Okay, we are going to go through all this relationship in our today's class.
Oh, okay. Thank you, madam.
Any other questions before we proceed for our class diagram? Okay, so I assume you don't have any questions. So I'm going to open. Okay, going to open. For class diagram. Okay, so this is today's topic. This lecture is about class diagram and design models. So I'm going to divide this slide into two weeks. So this week we are going to talk about only class diagram, and next week we will do the design models. Okay, so these are the lecture outlines. First, we are going to talk about analysis class diagram. And then next thing is evolving analysis models into design models. Then design interaction diagram and design class diagram. So most of our content for this topic is on analysis class diagram. Okay, so because we need to understand how to draw the class diagram, how to name the class, the relationship, and also the multiplicity and so on. So I'm going to go through this today. Okay, these are the learning objectives. First is to refine the sequence diagram and communication diagram during design phase, right? So actually, we have drawn the sequence diagram for PBL2 and communication diagram. So during this design phase, we will refine it, right, to make it, for example, when all the messages will be renamed to operations. So that would happen during refinement of sequence diagram. Second is to determine how to develop class diagram. So that will be covered today. And also to explain relationship characteristics such as degree and multiplicity, because we will be using this to show the relationship between classes. Okay, and then also to describe data relationship such as association, aggregation, and generalization. Okay, most probably you are already familiar with the class diagram, because they are actually similar to entity relationship diagram that maybe you have drawn for your database class. Okay, and also you are familiar with attributes and operations because you already took the object-oriented programming classes. So most of the things that we are going to discuss would be like revision for you. Okay, analysis class diagram. So this is the topic we have to cover today. Okay, class diagram. What is a class diagram? A class diagram is a static model that shows the classes and the relationships among classes. Right? So what are the classes that are involved in your system? If you are developing a student registration system, so you might have a class called student, you might have class called course, you might have class called lecturer, right? So you have to model those. So you have to represent those information in class diagram. So class diagram looks like this. You will have a rectangle. Each rectangle represents one class. And the rectangle is divided into three components. The first component is for the name, second component for the attribute, and the third component is for the operation. Then between classes, you will have one line that indicates the relationship, right, or the association. The next slide, elements of class diagram. So we are going to look at the components, as I mentioned just now, the class name, the attributes, and operations. So a class is a description of a group of objects with similar attributes, common operations, common relationships to other objects. Right? So it is represented using a compartmented rectangle. So what we mean by compartmented rectangle is the rectangle is divided into three compartments. Right? So as I mentioned, first compartment, you have to write in class name, attributes, operations. So this is an example of a class student, right? So this is the how we represent student information in our system using a class called student. So this class can have a lot of instances. So each student in the class would be one instance, right? For example, here we have Maria, we have David. They are all instances of the class student. Attributes are characteristics of the objects, right? So, for example, student, or you will have student ID, name, right? As an attributes. So usually we have to also mention what type, what is the data type, right, for that attribute. For example, name would be string, employee ID might be integer, right? So you have to name the attributes correctly, usually we use noun, right, to name the attributes. There are types of attributes: simple attributes, identifiers, multi-valued attributes, and composite attributes, right? So simple attributes contain single data item, right? Later we will look at example. Simple attributes contain single, means one data item. For example, like age, right? Age can be integer, a number, right? So that is simple attribute. Name also a simple attribute. Identifiers are numbers that you can make it unique. It's like ID, right? ID, that is identifiers. You make it unique so that you can differentiate one object to another object. Multi-valued attributes contain multiple values simultaneously. So we'll look at this example later. And composite attributes are a group of related attributes. So here we have identifier, right? Identifier attributes like student ID, because these are unique. So how to show that in the class diagram? We will use stereotype PK, right? PK stands for primary key. So that would be the unique identifier. No two student instances will have the same student ID value. Multi-valued, right? Multi-valued attributes examples here is like phone number, right? Because sometimes we will have more than one number. So you might have office number, or you might have two cell phone number. So phone number can take 2 values, 3 values, 4 values, right? So that is multi-valued attribute, can contain multiple values. A student may have several phone numbers. So how to show that? Just with a stereotype like this. We open this. Actually, there is a name for this symbol. I forgot what is the name for this symbol. If anybody remembers, maybe you can type it on the chat. Right, so we use that. Then for the composite attributes, all right, this is an example for composite attributes. For example, address, right? Address is composed of so many things. We can divide the address with a house number. We can divide it on streets, city, state, and also zip code or postcode, right? So we can just put an address here, but actually this address is a composite attributes. So we can have a separate class to represent address, and we divide the address into separate attributes. So we don't use a stereotype to represent composite attributes here, but we create a subclass, right? A separate class to represent composite attributes. Next, we go to the operations, right? So we have finished talking about attributes. Operations are actions or functions that a class can perform in manipulating the attributes. So examples are here: insert info, right? Verify password. These are all operations. And did you you can notice here that we use work, right? Work phrases. We use work phrases, but we connect them together, right? To represent it as a single operation. So here we have an example of class diagram that has name, attribute, and operation, right? So the drink is the name of the class, and the price of the drink is the attribute, and check the availability of the drink is the operation. Okay, now we go detail into some of the elements that we need to show in a class diagram. So this one we already discussed about the class name and the attribute and the operation. What we didn't discuss is this negative and positive symbol and also hash symbol, right? So when we put a negative symbol here, that means these are private attributes, right? These are private. And when we put positive, that means it's public. And when we put hash, it's protected, right? So what does it mean? It means that these attributes, company address, company email, and company fax, can only be changed by this class, right? Client has the right to change the company address, company email, company fax. Nobody else can change it, right? So it's private for the class. But company name can be accessed. So it's not a change only, but also access, right? To see the company name, or to retrieve your client's company name. It's public, right? When you put public, that means any other classes can access it, right? Protected only those who this class and also the class that inherit, right? We have the generalization relationship. Some later we will look at classes that inherit. We have parent class and subclasses, right? Child class. Also, child class can access, right, the company telephone. So it's a bit, it's like private, but a bit lenient. So because it allows the other classes who are under you to access. The same goes to the operation also. We use a plus symbol and a negative symbol to show the private, public, and protected, right? The next is stereotypes, right? What is stereotypes? Stereotypes is to show what kind of class it is, right? So it is it represents the classification of a class. So during analysis, we use this class stereotype, boundary or interface, entity, and controller, right? So I have been repeating these things when we draw our sequence diagram. I say that this must have interface object, entity object, and controller object, right? So for the class diagram also, we need to highlight this. Which class is interface, which class is entity, which class is controller. Sometimes we can identify it by the name, but what if we have a symbol that can identify it quickly? Then it will be better, right? So for the boundary or interface class, this is the symbol that we use, right? A circle, and then there is a key that is like a not a straight T, it's lying down, right? So this is the boundary class stereotype. Okay. So all the actors and other system, they communicate through the boundary class. So there is also another way to represent boundary. It's like this, right? If you write down, you open this stereotype, this bracket, and you write down boundary, right? Or you can just put a, you don't put boundary, you don't write down boundary, you just put this symbol, so we know that this is an interface class. Sometimes we just want to look at the relationship between the classes. We don't want to see what is the attributes and operation inside, so we can just show with the boundary, right? And then we do the connections. So these are all alternative notations for boundary class. For the entity class represents information and behavior in the application domain. So examples would be card, courses. So this is the alternative notation for entity class, right? A circle, and then we put an we put a line under, right? So alternatively, we can also name entity like this, right? Campaign. Campaign is the class name, so that remains, but we take out the entity and put a symbol, entity symbol. Okay, so remember that for the entity symbol and entity class, you need to put attributes, right? For boundary and controller, you don't need to put attributes. For the controller class, because they are the coordinator and controlling other objects, so we draw a circle with an arrow on the line, right? So this represents controller objects. So ATM manager, drink manager, these are all controller objects. So again, you can also use this way of representing controller object, right? So there's an alternative way of showing the notation. Now let's go to the relationship between classes. Okay, a semantic connection. This is the relationship, all right? A connection, but that connection got meaning. So a meaningful connection, right? You can say semantic means meaning. So semantic connection between objects of one or more classes. In UML, we represent relationship with a line, right? This line connect two or more classes. Types of relationship include association, generalization, dependency, and realization. Okay, so this figure shows a relationship between employee class and department class. What is the relationship? If we read the relationship, we can just read from left to right like this. Employee works in a department, right? Employee works in a department. Okay, you can put in more information for the relationship. You can put in the roles, right? So when you have a relationship works, that means employee is the worker and department is the employer, right? So this one is the role, but usually you will find that a lot of system developer, they will not show the roles in the class diagram because it's just complicating the diagram. So, but if you find a class diagram that has roles, don't be surprised. Okay, this is also a way of showing information in the class diagram. Next is the relationship degree, right? So if one class is related to another class, or only one class, right? So there is one-to-one, no one-to-one. It's a unary relationship. That means one class. This unary relationship is a relationship between objects of the same class, right? It's like a reflexive message in sequence diagram. Binary is between two classes. Ternary is between three different classes. Okay, example, this one is a unary relationship. So a person is a class. So a person can be married to another person. So to show that, we use a unary relationship, right? The association is a line that goes back to the same class, and we name the association married to. This is an example of unary relationship. Binary relationship is the normal example that we have seen here. This is called binary relationship. The one that we didn't see yet is ternary relationship between three classes, right? So if you look at ternary relationship, they are actually combination of binary relationship, right? So here, for example, ships has a relationship with vendor, with part, and warehouse. So there are three relationships. So this is called ternary relationship. Next is the multiplicity, right? Cardinality, multiplicity. What's the difference between cardinality and multiplicity? cardinality is how many instances of one class can be related to one instance of the other class, right? So that is cardinality. So when we say cardinality, then the multiplicity is the part of the cardinality, right? So multiplicity, the definition for multiplicity is cardinalities that specify the range of the number of objects in class A that can or must be associated with each object of class B. So multiplicity must be placed at each end of the association link, right? So here's an example. Before we go to the example, we have minimum cardinality and maximum cardinality, right? So the whole thing is called multiplicity, but if you look at one single one, it is cardinality. So here the minimum cardinality is 1, the maximum is 1. So the relationship becomes 1 to 1. If the minimum cardinality is 1 and maximum can be many, so it becomes 1 to many. If minimum many and maximum many, becomes many, many. And if you have fixed cardinality, for example, 1 to 5 becomes 1 to 5, or 5 to 6, and so on. So that is fixed cardinality. So here is an example of multiplicity. So how to read this? This is multiplicity. You put here 1, here you put 0 to n. So this one, 0 to n, means 0 to many, right? So how to read this? A movie is stocked as 0 to many videotapes, right? So is stocked as the relationship. So you have to read movie is stocked as 0 to many videotapes, right? If you have fixed cardinality 0 to 6, right? So how to interpret this? It's a question there. How to interpret this? We say instructor teaches 0 to 6 section, right? So the minimum, some instructor don't teach at all any section. Some instructor teach 1 section. Some instructor teaches 2, 3, and maximum would be 6. Okay, so that's how we read the multiplicity. Okay, this example shows all the things that we have learned so far: the class, the unary relationship, and the roles, and also the multiplicity in one single class. Okay. Multiplicity also can be shown for the ternary relationship like this. Okay, next let's look at the association cell itself, how to label them, how to name them, right? So association represents a relationship between multiple classes, class or itself. Is labeled using a verb phrase, right? I already mentioned this verb phrase, and can exist between one or more classes. Associations have many multiplicity, which represent the minimum or maximum times a class instance can be associated with the related class instance. So each end of an association contains a multiplicity indicator, right? Just now we saw examples with n, right, to represent many. But there are some books that do not use n; they use a asterisk symbol, right? So it represents the same thing. If you find asterisk, that means many. So I think these are, we are repeating, right? The same thing that I mentioned just now about association and multiplicity. Okay, this one is new. We want to talk about another type of relationship. We call it aggregation, right? Aggregation is a relationship that represents the association between two classes, but we represent a diamond, right? So what does that how does it different from the normal association? This type of association is to show part of, right? Part of that this class is part of this class, right? So class player is part of a team, right? So especially if a football team, you cannot have player without a team, because all the football matches they play in teams, right? So to show that kind of relationship, you use aggregation. So aggregations are used to represent one class as the whole, and the other represents the part. But it is a loose coupling. What does it mean by loose coupling? It means that if we destroy the team, right? If we don't have the team, will the player be destroyed too? No. Player still exists, but player exists without team. That's it, right? Player will not be destroyed. But if you have here a book, the class is book, this class is chapter. So if you destroy the book, will you have a chapter? No, right? So that kind of relationship is not aggregation, it's something else, right? So when the whole is destroyed, the part can exist, then you can show it in a aggregation relationship. Did you understand that? Was it difficult to understand? So when in a normal classroom, I can see your reaction on your face. I know that you understand or didn't. But here with the online classes, I can't see your reaction, so I have to ask you. Okay, so just remember, aggregation is for whole and part, but the whole can be destroyed, but the part will still exist, right? So that kind of relationship is loose relationship. So let's look at the second one, the composition, which is a hard relationship. So this one is a strong aggregation with tight coupling. That means the whole is the class that is a big, right? And the part cannot exist without each other. If the whole is deleted, the part are deleted as well, right? If the whole is deleted, for example here, cost registration. If you delete the cost registration, will you have the cost line items? Because the cost registration is composed of cost line items. That's why I call it composition. Cost registration, it has cost line items, right? So if you destroy cost registration, this one will be destroyed as well. So for those kind of relationship, we use a diamond with shaded symbol. So this is to represent composition relationship. In the video that I put in the UUM online, they have a very nice example for composition and aggregation. So I hope you can watch that video. And the explanation is very easy to understand. So that's why I choose that video for you to watch. So that will help you to understand these two relationships. The next relationship is the generalization relationship. So this is to show the subclass and the superclass. So employee is the superclass, and nurse, doctors, and pharmacists are the subclass. So they inherit all the attribute and operations from the superclass, right? So to show that, we use a solid line with an arrow, but actually the arrow should be hollow, right? In this example, the arrow is shaded. It should be hollow arrow, right? Even these examples, the arrow is shaded. So in this example, you can see that there is a superclass called employee, and there are subclasses called hourly employee and salaried employee. So they are both child of employee, right? Or subclass of employee. So they inherit all the attributes: employee name, employee number, address, employee date hired, right? They have that. Also, they have their own attributes, like hourly employee have hourly rate, and salaried employee have annual salary and stock options. Okay. The next is to what are the steps to build a class diagram? First, you have to set the context, right? Make sure all classes that are involved in the system are there, and then you have to identify which class is boundary class, which class is control, and which class is entity, right? So for the all the classes, you can define the operations. You can look at your sequence diagram to identify all the operations. Then for the entity class, you have to define attributes, right? Only for the entity class, you define attributes. Then after you done that, you can draw the relationship between the classes, and don't forget to set up the multiplicity, right? So these are the steps. Actually, we are now at the end of the class, right? So because I told you that this one I will leave it for the next class. So any questions? Theories? Yes, you can say theories. But all these are not new for you, right? You have came across these things in entity relationship diagrams, maybe. Okay, so I have prepared an exercise for you, okay, which I have already uploaded in the UUM online learning. But this exercise I will ask you to do it not in class. You can do it now, right? But the discussion of the answers I will discuss it in our next class. The time left now is dedicated for those groups that did not check the sequence diagram yet. Okay, so the rest of this class who I have already checked their diagram, you can do the exercise now, right? You can leave the meeting and do the exercise because you still have time before your second class or other class begins. So you can do the exercise and keep the answers so that we can discuss the answers next class. Next class, I would like to, whatever you have drawn, I want to see it, right? So answer the exercises in a piece of paper, scan them, and keep it in your laptop so that you can share with me next class. I want to see your answers. Is that clear? Okay. Okay. All right. So I think that's it for today. You can go, except for 4 groups. PBL group, I need to check your sequence diagram, so you have to stay back and show me the sequence diagram. Okay, let me see which group have already checked. I have already checked buddy group, right? Buddy, I already checked. I have already checked Zexgen Sdn Berhad. I have already checked SAD clothing. I have already checked Divya's group and Daniel group, right? So other groups, so you know who you are, stay back. The rest can leave the meeting. I will see you on Thursday. Thursday, show me the class diagram that you have created for your group, right? So you continue on to create class diagram. So we will have only class diagram checking on Thursday. Quiz 2 will be next Thursday. Topic 3 and 4. Okay, so that's it. I will see you on Thursday. Stay back only the group that I didn't check the sequence diagram yet. Don't forget to do the exercise. I want to see the answers next class too. Okay, which group that I didn't check your sequence diagram yet? You're welcome.
Madam,
Yes.
can I share my screen?
Yeah. Which group are you?
I'm from Music and Artist Information System.
Again?
Ahmad Nazir Group.
Okay.
Yes. Yes.
What's the name of the company? I forgot.
Teradata.
Oh, okay.